Now the seventh problem, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So let us consider a triangle A, B, C, and let D be the midpoint of AB, and let L is a line through D parallel to BC meeting AC at E. So D is, since D is the midpoint of AB, D is the midpoint of AB, that is the ratio of AD by DB, this will be same 1:1. So therefore AD by DB equal to 1, and also it is given that L is parallel to BC. L is parallel to BC, that is DE is parallel to BC. So therefore, since DE is parallel to BC, by using BPT, we will have the same ratio for AE by EC also. AE by EC also will have the same ratio as AD by DB. So the ratio of AD by DB is 1 because it's the D is the midpoint of AB. So therefore AE by EC equals to 1. So that means this ratio is 1:1. So therefore the conclusion is that E is the midpoint of AC. So that is what we have to prove. Now, eighth problem, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So we'll take a triangle ABC, and we have to prove that the line joining midpoints of any two sides. So we'll take D as the midpoint of AB and E as the midpoint of AC. Then we will have to prove that the line joining the midpoints DE is parallel to BC. So since D is the midpoint of midpoint of AC, the ratio will be AD by DB. AD by DB is equal to 1. This will be 1:1, and similarly, since E is the midpoint of AC, AE by EC is also equal to 1. So that means the ratio AD by DB is same as AE by EC. AE by EC. Now applying the converse of basic proportionality theorem, by using converse of basic proportionality theorem, we can conclude that DE is parallel to BC. So that is, the line joining the midpoint of the two sides will be parallel to the third side. So that is what we are asked to prove.